as I have informed during my last class, is the last topic of this microprocessor. It is I/O interfacing. So I have already told you there are two types of I/O interfacing. One is isolated I/O, or is called as I/O mapped I/O. I have explained you the difference between I/O mapped I/O and one more time, which is called as memory mapped I/O. Right? With an analogy I have explained you during my last class. Hope if you are there, if you remember what was covered in the last class, you will be knowing about it. Isolated I/O or I/O mapped I/O. What is this? In simple, I can say your microprocessor and I/O is directly contacted, okay, through a I/O pin. Okay. See what is happening here is every microprocessor will have its address generated to locate the I/O, whichever I/O is connected. Okay. See, in isolated I/O, memory address space is different from I/O address space. What is this? Memory address space is different from I/O address space. I have explained you about this. Okay. During last class, I have explained you. This is your microprocessor, and these are all I/O devices. These are all I/O devices. Okay. These are all I/O devices. So there is a I/O read and I/O write. You know, you have a memory and I/O bar. Yes or no? You have memory and I/O bar, right? And you have a read signal and you have a write signal. Suppose if you give 0 to this particular pin, that means microprocessor, your 8086 microprocessor is doing read and write operation to the I/O. Hello, my dear. To the I/O. Okay. If this particular signal is 1, then microprocessor is doing read and write signal to memory. Right? Hope you are understanding this. Okay. See, you have this memory also connected to this microprocessor. I/O also connected to microprocessor. Now, how do you differentiate reading and writing to memory and I/O? This particular pin, right? If you give 1 to this pin, it is doing read and write operation through memory. If you give 0 to this particular pin, it is doing read and write operation to I/O devices. Okay, that is the difference. Okay. Okay, so signal used here, as I told you, it is I/O read and I/O write. Signal used here is I/O read and I/O write. See, that's what I have told you here. See, memory bar I/O, as I told you that when the signal is 0 in this, okay, it is actually selecting this I/O devices. When the signal is 0 on this, can you tell me whether memory is selected? When the signal is, I told you, when the signal is 0 on this, okay, this is select bar, right? This is enabled. Can you tell me whether memory is enabled same time? Memory is not enabled, right? See, this memory / I/O bar either will select memory or I/O device. Whenever the signal on this is 1, see here, whenever signal on this is 1, can you tell me what it's supposed to be? Memory, right? Yes or no? And you have a NOT gate here. So 1 will become 0 here. 1 will become 0 here. That means what is selected? Memory is selected. Okay. Now whenever the signal is 0 on this, now what will happen to memory? Memory will not be selected. Instead of that, what will be selected? I/O is selected. Have you understood now? The purpose of having memory slash IO bar, this is what the example. Okay, and in isolated IO, we use this. Okay, whenever we communicate to the IO devices, this is something direct connection to the IO device, direct connection. Okay, this is called IO, map IO or isolated IO. Okay, what exactly is this? Hope you know why I am telling this. This is IO interfacing. We are interfacing input-output devices to microprocessor. And I am telling you that there are two ways you establish interface, you establish connection. One is IO map or called as isolated IO, right? Another type is called as memory mapped. It is through memory. I gave you an example also during my last class. Another one is memory mapped IO. In memory mapped IO, we don't use the instruction called in out. Right? What is the in and out instruction? Right? Try to understand very clearly. In the previous case, if you want to put any data to the IO device, we use an instruction called as two instructions called as in and out. Okay, try to understand very clearly about this. Okay, see, what is this in and out instruction? I just want to tell you. Okay, just try to understand this. This is your microprocessor. Okay, this is your 8086 microprocessor. Okay, and you all know that this has D15 to D0 data bus, and all of you know this has an address bus starting from A19 to A0, and it has got M/IO bar. It has got a read signal and it has got a write signal. This much is enough to represent your input-output devices. Try to understand this. Okay. Now you have IO device here. Okay. I will consider this as an IO device, and this IO device has got a select pin. Okay, select pin, and also this has got a read pin, or this is also this has got a write pin. Assume that this IO does both read and write. Okay, this IO is something which does both read or write. Okay, if this IO is a temperature sensor, okay, then it is only trying to read the data. If this sensor is an LED, if this IO is a 7-segment LED, it is microprocessor is writing the data. Have you understood about it? Okay, consider this IO is capable of doing both read and write. Understood this? Now, see here. It also has a data line. It requires data, yes or no? This IO device is supposed to give data to microprocessor. That is, microprocessor is reading the data, and also it accepts data from the microprocessor. That means microprocessor writes the data into this. Right? Microprocessor can read the data from IO device. Microprocessor can write the data into the IO devices. So for that you require data lines, right? Yes or no? Come on, no. Yes. So assume that you are actually giving 8-bit data. Assume that this IO device is capable of giving out and taking in, okay, 8-bit of data. Have you understood this? Okay, this is about your IO. Now, microprocessor wants to write some data into this. Assume that microprocessor wants to write a data into this. Okay, what is the first step microprocessor does? Microprocessor first identifies this IO device. Okay, how does it identify this particular device? Using address lines. Okay, you have something called address decoder here. Okay, you have something called address decoder here in between. Like you have address decoder for memory, right? For IO also you have address decoder. It will make use of your address lines, an entire address line, and it will locate that IO device. Like it used to locate your memory. All of you know about it. Okay. Then what it does, okay, first it will locate the IO device. Once IO device is located, if microprocessor wants to put data to the IO devices, it is using one instruction called as out instruction. Out instruction. And this out instruction will give data from microprocessor to the IO device. That means whenever out instruction is executed by 8086 microprocessor, you can see that the data will be put on the lower order data lines here. Suppose if you are putting only 8-bit data, you don't require higher order data lines, right? Only lower order data lines, that's 8-bit data will be put into this IO device. We will see the syntax of out instruction. In out instruction, we are going to specify the address also. We are going to specify the address also. Which address this particular data is going. I have understood this. Okay? Yes or no? You have used the in and out instruction. Where? Already in the laboratory you have used the in and out instruction. Right? So, what is the syntax of out instruction? Do you remember syntax of out instruction? You've done the programming, right? You've done
Out bx comma
out
bx comma
bx comma
al
8
al.
al. What is that? What is the dx? What is the al? The syntax of out instruction is here out. Since you are using 8255, you are using 85 instruction. Otherwise, this is going to be your address of the port, out address, comma, what you are going to put? Data, right? Data. The data can be in any register, right? The data can be in any register of the microprocessor. So, like it can be AL, BL, whatever. This instruction writes the data, okay, into the IO devices. From where it writes? From the microprocessor. Similarly, don't you think we need to have an instruction? Like microprocessor writes the data to the IO. Microprocessor can also read the data from IO, right? Yes or no? Yes or no? So what is the instruction for you? Tell me. Come on. What is the instruction for reading the data from IO device? Come on, this is very bad. This is out instruction is to write the data into the IO device. What is the instruction to read the data from IO device? What is that instruction? Come on, you have done it in the lab, right? Have you done any instruction in the lab? You are not done, right? You have done only out. Can you guess what means the instruction? If out is going, if writing is out, what will be the instruction to read the data? Can you guess? Of course, it is going to be in instruction, that's all. Once again, here you will have a port address, data and port address. Right? Data and port address, that's all. Right? This also consists of your AL, comma, address. It is writing data into the AL register. Syntax exactly we see by writing the program. That means in IO mapped IO, or we call it as isolated IO, we use this in and out instruction, right? This is the way it writes. I'll repeat once again how your microprocessor writes or read data into IO or from the IO. What it does, first it will identify the IO device. Which IO device? Okay, through address, right? It will generate an address. Once it identifies it knows which address is that, right? This address. Now it writes the data into the IO, maybe from AL register, maybe from whatever registers you have, okay, through an instruction called as out instruction. At that time you can see the lower order data lines of microprocessor will have the data which is to be written into the IO device. It will just write. Then similarly, if microprocessor wants to read a data, right, you have an instruction called in. Anyway, address is written in the instruction itself. Okay, and what is the data where the data to be read, right? That will indicate it by a register here. See, once microprocessor wants to read the data from IO device, where it is going to keep the data? Come on, tell me. It has to keep it in its own registers, right? Okay, so that is what you are mentioning in this. So this method of exchanging the data between microprocessor and IO directly by locating the address is called as IO mapped IO, or called as isolated IO. Have you understood this now? Right? Okay. Now what is another method? What is another method? Another method is through memory. Through memory. Here, is there anywhere memory is involved here? Tell me. Nowhere memory is involved. I'm directly actually writing the data to the IO, and I'm directly reading the data from the IO to the microprocessor. I'm not going to involve any memory here. I don't want the memory in this type of method. Okay, now can I involve memory in this? Right? That is called as memory mapped IO. That is called as memory mapped IO. In this, we are not going to use your instruction in and out. Right? We are not going to use the instruction in and out in this. We don't want. Why we don't want this instruction in and out here? Because we are not going to directly send the data to the memory, to the IO, or we're not going to get the data directly from the IO. Now, here what we do, we don't use an IO read, IO write signal at all. Right? We don't use any IO read and IO write signal at all. But instead of that, we will use memory to contact the IO. Have you understood this? We'll use memory to contact the IO, where your IO device and memory, they have got married. They are connected. Right? They are connected. Okay. So since they are connected, whatever data you put into the memory, it will go to the IO. Have you understood this? Okay. In memory mapped IO, it works something like this. You have your microprocessor here. This is your 8086 microprocessor. This is your memory. This is your memory. Okay. And this is your IO device. Assume that this is your IO device. Okay, which does both read and write. Now, ultimately purpose is to put the data into IO, get the data from IO. Yes or no? Microprocessor wants to put the data into IO, or it wants to take the data from IO. Okay. So instead of contacting directly using IO read and IO write, what it will do? See, there are some memory locations in this. Some memory locations in this is reserved to get the data, to put the data from IO and to get the data from IO. I've understood this. So what it does, if at all IO device wants to send the data to 8086, first it will put it in the memory. It will put it in the memory. Whatever, see, this exchange is actually happening always. Whenever your IO device wants to send the data to microprocessor, it need not give interrupt the microprocessor here. It will put it in the memory location. It will directly put it in the memory location. Now, what microprocessor will do? Whenever microprocessor wants to read the data of IO device, microprocessor will not look directly into this, but it look into the memory. A particular memory location is reserved, fixed for this IO device. So, what microprocessor will do? Microprocessor will generate that address and it will make use of memory read and memory write instead of IO read and IO write to get the data from the IO device. Hope you're understanding this. Right? This is called as memory mapped IO. There are two types of IO operations we have discussed now. One is IO mapped IO and the other one is memory mapped IO. In memory mapped IO, we directly get the data from the memory. That's all. We don't use in-add instruction. Have understood this? Right? Okay. So these two are different types of IO interfacing. Okay. Now you understood how to interface the data, read and data write to microprocessors. So this is what I have told you. It will directly, okay, it will directly say this is the total memory. In that memory, some of the memory spaces are reserved for IO operation. Right? What is the meaning of reserving this memory for IO operation? Tell me. That means whatever memory location you have here, this is having the data from IO devices. Whenever microprocessor wants the data from that IO device, it will look into this memory location. Have you understood this now? Yes or no? Okay. Let us go forward. So these are the memory mapped, memory plus IO mapping. So these are the memory divisions. Let us talk about now interfacing. How do we interface either switch or an LED to 8086 microprocessor? Okay. Now you see here. What is this? Tell me now. What is this? Come on.
Switch.
This is a switch. Right? Is it not a switch? The switch. Now, can you tell me what happens to this A when the switch is closed? Just a small electrical sciences question to when the switch is closed, it will be zero, right? Why it will be zero? Because it will be grounded, right? Zero. It will give zero. Now, when the switch is open, it will give 1. Right. So this can be connected to one of the data line, yes or no? Where D0 will receive 0 and 1. Have you understood this? Right? Okay. So this is simple switch. And then we have, I already told you about, what is this? Tell me. This is not the correct symbol for LED. So normally LED is, you need to have arrows. LED symbol is, you will have a diode symbol and then you will have an arrow, 2 arrows. That is the correct. When in the examination, please don't do this mistake. Okay? In the class, that's why I'm telling you, your diode symbol is this one. What is the light emitting diode symbol? There are 2 arrows in this. Fine? Remember this. Can you tell me what happens if I give 0 in this? We are working with only zeros and ones, right? In microprocessor, we are working with only zeros and ones, right? So what happens if we give 0 here? Whether LED will glow? No, right? Because you have this is p-type. If you give 0 here, it is reverse biased, right? Right, okay. Now, suppose if you give 1 here, it is forward biased, right? Your diode is forward biased because 1 means 5 volts, huh? So this will be positive. and this is in the lower voltage. So this definitely this diode will be forward bias. But this diode is forward bias, what will happen? Tell me. This LED will glow. Come on. LED will glow. Right? Okay. So now how do you give this? How do you make your microprocessor to make this LED on and off? Tell me. I want to make this LED on and off. Let us use IO mapped IO. What data I should give to make this LED on and off? Imagine that this is connected to D0. Can you tell me? What use which instruction is supposed to be given executed for microprocessor to make this LED on and off? Is it reading the data or writing the data? Writing the data, right? Which instruction is to write the data? Out. Okay, address. This address corresponding to this IO device. Can you tell me what data I should give? Okay, I will just put the data into AL register. What data I should give to make the LED on? Exactly 0 1, right? Okay, see, you put 0 1 into AL register and you just execute an instruction out comma address comma AL. What will happen now? Tell me. So microprocessor will put 0 1 into the D7 to D0, right? Where D0 is connected here. So what will happen to this LED? It will glow. How do you switch off the LED now? You have to put, how do you switch off the LED? How do you switch off the LED? Move AL comma 0 0 H. Now once again execute out address comma AL. That's all. Have you understood this? Right? We are not using memory mapped IO here, but we are using IO mapped IO in this. Okay. So this is a type of. Okay. So I have told you about this now. And in instructions, I already told you about in instruction. What is the in instruction? I told you. See, in accumulator comma port. What is this port? Port is nothing but the port address of the IO device. The IO device address is called port address. Why it is called port address? Because normally your 8086 microprocessor data lines are not directly connected to IO. Listen to this. Okay, it is connected through another integrated circuit called as programmable peripheral interface, which is called as 8255. Right? Remember this. Your microprocessor, your data lines are not directly connected to the IO device. It is connected through another device called as programmable peripheral interface, which has multiple ports, which can be programmed, okay, to have access through an address called as port address. Hope you remember when you are typing the program, okay, I know you are blindly making cut and paste, copy and paste, okay. In the first few lines, you have written port address, port A with port address, port B with port address, port C with port address. Then you have one more control register. What is the purpose of that? That is where you program your 8255. That is programmable peripheral interface. Right? That's what this port address is. So in accumulator port address, what it does? Whatever data copied, this is in means what? In means microprocessor getting the data from IO device. Whatever data read from the IO device, okay, with the device port address will be copied to accumulator. It can be either AL or AX. Can you tell me when we use AL and when we use AX? You answer my question, my dear. Whenever you are reading 8-bit data, you use AL. Whenever you are reading 16-bit data, you use AX register. That's all. So, for example, see in AL00H, okay, in AX 20H. Can you tell me what is this? It reads a data from an IO port, from IO device, from IO port with address 00H, okay, and puts it into the A register. That means it is reading 8-bit data. Similarly, this reads a data from a IO device with port address 20 and it copies the 16-bit data into the AX register. This is what your in and out in instruction is. Okay. Now, can you tell me? Can you guess? Your address can be either 8-bit or 16-bit. Okay. I already told about this. The port address appears on the address bus during the IO operation. So 8-bit address is this one. It copies the data from the port to the. I already explained you this. Whatever is there in the slide on the slide, I already explained you this. Okay. In instruction, okay. This is also possible. See here. This is just a programming, right? See, we are writing in, okay, in AL, comma port address. This is the port address, right? This is the port address. If this port, this is normally 16-bit port address. Okay. You can put the port address in a DX register, right? Okay. And then here you can put in AL, comma DX. Of course, we are using one more statement, extra statement here. Maybe if your program requires that, you can put this in the DX register and you can indicate here. That means this DX register is having what? This is having address of the port. That's all. It's nothing, no other significance in this. Okay, fine. This is just a programming. This is the way you can do the in instruction. Okay, port address. Out instruction. Can you guess out instruction? In out instruction, what comes here? Port address first. Is the port address. Okay. In instruction, your port address comes next. Okay. In out instruction, port address comes first. This is the port address. So can you tell me what this instruction do? Tell me. It writes an 8-bit data into the IO device with the port address 05H. Similarly, this copies a 16-bit data from the microprocessor to the IO port with the address 03H. That's all. And this port address can be in DX register also. Okay, that option is there for you. Okay. I already told about in and out instruction. It can be out, immediate port 8 address, AL, out, immediate port address, AX, out, immediate port address, EAX. Can you tell me what is this, EAX? This is for 32-bit, okay? And similarly, you can put the address in the DX register. I understood this, okay? These in and out instructions are very, very important for you, okay? Now, okay, so once again, you can use even and odd addressing here. Can you tell me what's the purpose of using even and odd addressing here? Tell me. What is the purpose of using even and odd addressing in memory interfacing? To get 16-bit data at a time, right? Don't you think that some of your IO devices are giving you 16-bit data? Yes or no? Right? In that case, you need to have these data read from the two addresses. That's where this even and odd addressing comes here. Right? See here. your lower order byte data either can be read or written using even addresses. Okay, like you have done it for memory interfacing. Similarly, your higher order data has to be read or written using odd addresses. So whenever you design an I/O interfacing, if you want to read a 16-bit data, okay, your I/O device, the data transfer has to be arranged in such a way that it will give, it will have two port address, it will have two addresses, it will have two addresses, and it will give 16-bit data from the two addresses. I understood this. Okay. Imagine this I/O device is giving 16-bit data. Okay. Right. Okay. Imagine this is giving 8-bit data 2 times. Okay. This I/O device is having 8-bit. Okay. Since microprocessor is having, see, this is where you have to use even and odd address. See, this is your 8086 microprocessor, okay, and it has got 16 data lines. If your one I/O device, okay, is giving you 16-bit data, if this giving you 16-bit data, can you tell me, do you need even and odd addressing? You don't require even and odd addressing. Okay, remember this, because your I/O also can handle 16-bit data and your 8086 also can handle 16-bit data. Now, suppose you have two I/O devices. This is 8-bit. This is also 8-bit. Right? And both the devices can simultaneously put the data into microprocessor. How it can do? Come on, I told it down. You put this, you give even address for this, you give odd address for this. Right? I've understood this. See, 8086 has the capability of reading 16-bit data, right? Yes or no? It has a capability of reading 16-bit data. Suppose if I have two I/O devices separately sending 8-bit, right? Why I should send these two data separately in two machine cycle? Why I should do it? Right? Instead of that, I can give an even address for this, and I can connect D7 to D0. I can give odd address to this. I can connect D15 to D8. So I can read both the data through D6, D15 to D0. Okay, even from the even address from here, odd address from here. That means this particular I/O device will have even address. This particular I/O device will have odd address. So it will read a 16-bit data at a time from even and odd address. I've understood this. Okay, this is the way you can use even and odd address to get the 16-bit data, right? But remember, if that 16-bit data coming from one device, do you need a even and odd address? No, you can connect this directly D15 to D0 and D15 to D0 of the microprocessor. This is D15 to D0 of microprocessor. So it can do it, data transfer in one machine set. Right? Suppose you have two I/O devices. This is also 8-bit, this is also 8-bit. Both can do the exchange of data to microprocessor at a time, provided you give even address to this and odd address to this. This is very important to understand. Okay, that's why this even and odd addressing comes in I/O interfacing also. So how do you separate even and odd address? How do you decode? Using A0. You all know A0 is always 0 for even address. A0 is always 1 for odd address. Okay. So we will see remaining thing in the Monday's class. Okay. So So try to revise this once again. I have recorded this lecture. I will